What if a chemical engineer could automate complex calculations, predict plant behavior, optimize industrial processes, and even build intelligent models using just a few digital tools? Artificial intelligence is no longer limited to computer scientists, it is becoming a practical skill set for modern chemical engineers. Hello everyone, welcome back to Chemical Engineering and Aspen channel, and welcome back to our AI in Chemical Engineering lecture series. In the previous two lectures, we discussed the fundamentals of artificial intelligence in chemical engineering and explored how AI is being applied for process optimization, predictive maintenance, and digital twins. In today's lecture, we will focus on a very practical question, that what tools should a chemical engineer learn to start working with AI? This lecture is particularly useful for students, researchers, and young professionals who want to prepare themselves for the future of chemical engineering. The chemical engineering industry is undergoing rapid transformation. Traditional engineering is now merging with data science, automation, and intelligent decision-making systems. Industries are moving toward Industry 4.0, where plants are becoming smarter, more connected, and increasingly automated. Modern engineers are no longer expected to only understand reactors, distillation columns, and heat exchangers. They are also expected to analyze process data, automate workflows, and support AI-driven decisions. This means AI literacy is no longer optional, it is becoming an engineering skill which is essential requirement. To become future ready chemical engineer, three things are required. First is the domain knowledge. This includes thermodynamics, reaction engineering, transport phenomena, process control, and process design. Second is data skills, that engineers should know how to collect, clean, analyze, and visualize industrial data. Third one is AI capability, which includes machine learning, automation, optimization, and predictive analysis. The engineers who combine all three areas will be most valuable in the coming years. So we will now talk about the first and most important tool every chemical engineer should learn is Python. It is widely used because it is beginner friendly, powerful, and supported by a large ecosystem. Chemical engineers can use Python for data analysis, automation of repetitive calculations, process optimization, machine learning model development. The important libraries which are included is NumPy for numerical calculations, Pandas for data handling, Matplotlib for visualization, and Sky or SciPy for scientific computing. For example, you can automate mass and energy balance calculations or analyze plant operations data using Python. It is a foundation upon which most AI workflows are built. After learning Python basics, the next step is machine learning libraries. Scikit-learn is ideal for beginners. It is commonly used for regression, classification, clustering, and model validation or evaluation. Now, examples include predicting product yield, estimating equipment efficiency, and detecting abnormal operating conditions. For more advanced work, engineers can use TensorFlow or PyTorch. These libraries are used for deep learning and neural networks, and their applications include time series forecasting, fault diagnosis, and soft sensors development. Next tool is another essential tool is Jupyter Notebook. It provides an interactive coding environment where you can combine code, equations, text explanations, and plots in one place. This makes it very useful for learning, research, teaching, data analysis, documentation. It is widely used by students and researchers because it supports experimentation and reproducibility. Number four and last tool for our today's discussion is Aspen Plus, which remains one of the most important industrial tools for chemical engineers. It is mostly used for process simulation, equipment design, sensitivity analysis, economic evaluations. But now Aspen can also be integrated with Python. This creates exciting opportunities. You can automate simulation runs, generate training datasets, and optimize process conditions using AI models. For example, simulation data from Aspen can be used to train machine learning models for distillation optimization. Now, if we talk about the career opportunities that AI skilled chemical engineers can access diverse career opportunities, which include process optimization, data science, automation engineering, process control, sustainability analytics, R&D, and digital transformation. And industries that are actively adopting these skills include oil and gas, pharmaceuticals, food processing, petrochemicals, and specialty chemicals. To summarize, AI is reshaping chemical engineering. Python is the foundational skill. Machine learning libraries enable intelligent modeling. Aspen Plus remains industrially critical. Visualization and version control improve productivity and professionalism. The future chemical engineer will not only understand chemical processes, but also data, automation, and artificial intelligence. Thank you for watching. In our next lecture, we will discuss AI research opportunities in chemical engineering. Please like, share, and subscribe for more lectures in this series.